Okay. I'm just looking at the homework, just kind of like going through them, just like before I do them, so I don't mess them up. But I feel like I think I cut myself off there, but it just feels like everything uses Pythagorean identity. So it feels like it's going to use our three popular ones. So like, or cosine squared theta plus sine squared theta or whatever. The order doesn't matter. You have commutative property of addition. And then you have tangent squared theta plus 1 is equal to secant squared theta. And then you have cotangent squared theta plus 1 is equal to cosecant squared theta. You just have like a bunch of stuff. By the way, if you take this, and I think we mentioned this in another video, this is sine squared theta is equal to 1 minus cosine squared theta. Like there's the three main ones, and then these are kind of like a couple of other random ones. But when you do this, you got to keep these in mind. In theory, you only have to keep this one in mind. In theory, you only have to keep that main one, sine squared plus cosine squared is equal to 1, or cosine squared plus sine squared equal to 1. Yeah, that's the only one you really, really have to kind of remember. But the other ones are going to make it easier to know. I'm almost like want to prove it to you, but I'm going to start with 1. I got cotangent theta plus tangent theta is equal to secant squared theta over tangent theta. And our goal is to get the left-hand side equal to the right-hand side, or the right-hand side equal to the left-hand side. You just got to pick a side. And I'm going to pick the left-hand side. Yeah, I'm going to pick the left-hand side. Man, this is a tangent theta. All right, and so when I take the left-hand side, cotangent theta, oops. Uh-oh, no. Excuse me. When I take the left-hand side, cotangent theta plus tangent theta, and I multiply by 1 over tangent theta. Okay, obviously I can't multiply by 1 over tangent theta. I'm going to multiply the numerator and the denominator by tangent theta. I think good stuff's going to happen. When I distribute to each term, cotangent theta times tangent theta, that's going to turn into 1. They're reciprocals of each other. And then tangent theta times tangent theta is tangent squared theta. And this is going to be all over tangent theta. And again, going back to one of our Pythagorean theorems, I know that 1 plus tangent squared theta is secant squared theta. So I get secant squared theta over tangent theta as my answer. I know for me, like when I get stuck, I go into sines and cosines, and you get the same stuff. It'd just be like 32 more steps, or however many more steps. It's going to be a little clunky. All right, so sine theta equals secant theta over tangent theta plus cotangent theta. Okay, so since my answer is sine, I'm probably going to get everything into sines and cosines. And not that this is an obvious statement, but I'm going to start with the right-hand side. So I like starting with the side that looks more complicated in most cases, not all cases. And then it's easier to simplify it down to something versus adding. Okay, so I can rewrite this using reciprocal functions as 1 over cosine of theta, all divided by sine theta divided by cosine of theta plus cosine of theta divided by sine of theta. And this almost goes back to like our rational function unit. Excuse me. I want to eliminate fractions, right? I want to eliminate fractions. And I think I can do that. If I multiply the top and the bottom, I don't know if I'm going to do common denominator or fractions. You know what? I'm going to do common denominator. So I'm going to simplify the bottom fraction. I was going to do something else a little trickier, but I decided to go this one. It might be simpler. So on the bottom here, these guys, the least common denominator is cosine theta times sine theta. And the first term is missing a sine theta. So when I multiply the top and the bottom of the very first term, I'll get sine squared theta over, over cosine squared theta, or cosine sine, but we're going to have the same denominator, so I'm just going to skip a step there. And then when I multiply here, when I multiply this guy, I'm going to multiply the top and the bottom by cosine because the denominator is missing a cosine. So I get cosine squared theta. And then finally, I get just the denominator cosine theta times sine theta. And then I know what this turns into. That just turns into 1. So I get 1 cosine theta over 1 divided by cosine theta times sine theta. When we're dividing fractions, we multiply by the reciprocal. And so we get 1 over cosine theta times cosine theta times sine theta. And then, these guys cancel out. And you just get sine theta as your answer. That's a pretty decent problem. I like it. Do I like it for number 2? Probably not. It's going to be really, really long homework. I'm shooting for that 20 minutes, hopefully. So I get tangent squared theta times cosecant squared theta, as this is my number 5, is equal to 1 plus tangent squared theta. And I don't know, both sides look kind of blah. I'm not sure where I'm going with this. Left, right, left, right, left, right, left, right. Okay, I think I'm going to go right. All right, 1 plus tangent squared theta. All right, so I want to get to here. And I have a tangent. Oh, I know it. 1 plus tangent squared theta is secant squared theta. Okay, I'm going to continue. Secant squared theta is 1 over cosine squared theta. And again, I guess the thing about verifying or proving identities is we know where we want to end up at. So, I want a tangent. I want a tangent squared, and I have a cosine squared. So if I multiply the top and the bottom by sine squared, I will produce a tangent squared. So, I can, commutative property of multiplication, I can change that order, and I can say this is sine squared theta over cosine squared theta times 1 over sine squared theta. And then I can just convert them. This is going to turn into tangent squared theta. And then this is going to turn into cosecant squared theta. All right, on to 7. Making okay time, I guess. Tangent squared theta plus 1 over tangent squared theta equals cosecant squared theta. And let me restate this. There's not one correct way of doing this. Technically, you can get everything into sines and cosines and go to town, and maybe that'll be easier. I don't know, but I'm gonna go left-hand side, obviously, maybe. Tangent squared theta. I know that's secant squared theta over tangent squared theta. The first one is going to be 1. The numerator is going to be 1 over cosine squared theta. I'm stuck. I'm officially stuck right now, so I'm gonna change it to cosines and sines because that seems to be a pretty decent technique. Tangent is sine squared over cosine squared theta. And when I'm dividing fractions, I multiply by the reciprocal. So I get 1 over cosine squared theta times cosine squared theta over sine squared theta. The cosine squareds cancel out. You get 1 over sine squared, which is just cosecant squared theta as my answer. Am I doing the next one? Yeah, 9. Okay, so here's 9. Whoa. Man, why does this look so hard? What are you doing to me, textbook? No, it's good. It's good. These are supposed to be challenging, and you'll get the hang of it. Actually, this one's not challenging. Secant squared theta over cosecant squared theta. I feel like we did this one. Okay. I'm starting with the right-hand side. So I get 1 minus cosine squared theta plus secant squared theta over cosecant squared theta. It turns out that 1 minus cosine squared is sine squared theta. I have it here as one of my, Pythagorean theorems to know. One of these guys. But if you forget, just plug in. If you forget, just make sure you plug in cosine squared plus sine squared is equal to 1. All right, plus, okay, I'm going to rewrite this one because I'm kind of stuck with that. I'm going to rewrite this as 1 over cosine squared theta divided by 1 over sine squared theta. And then you can easily see that this is going to turn into tangent, but I'll do it in steps here. So I'll get sine squared theta plus 1 over cosine squared theta times, you're going to multiply by the reciprocal. This is sine squared theta over 1. And so you get sine squared theta plus tangent squared theta. And we're done. There we go. All right, on to 10. No, wait, on to 11. On to 11. Okay, 11. I get cotangent theta. Cotangent theta plus tangent theta equals cosecant squared theta. Okay, get a little tired. Get to re-energize or something. Distribute. Yes, I'm going to distribute. I'm going to start with the left-hand side, cotangent theta plus tangent theta, and then I'm going to distribute. So when I distribute, that's going to be cotangent squared theta plus 1. Wow, they're really honing you on, they're really hammering you on this. This is one of our Pythagorean identities, and I believe it's cosecant squared theta. I don't know, somewhere right here. Boop. Yep, cosecant squared theta. Excellent. So this is cosecant squared theta, and we're done. On to 13. Sine theta times secant theta times cotangent theta. All right, equals 1. Obviously, I'm starting with the left-hand side. I feel like I should just start with the right-hand side and build it up, but I don't know if I'm that good. All right, so sine theta times 1 over cosine of theta. I'm just getting into sines and cosines. Let's see, cosine of theta over sine of theta. These cancel out, and this cancels out, and this is equal to 1. Done. Easy. All right, these are easier. The other ones seem harder. Let's see, 1 minus 2 cosine squared theta over sine theta times cosine theta is equal to tangent theta minus cotangent theta. Okay. Don't know what to do. Left-hand side? Right-hand side? Where to start? I'm going to go left-hand side. I'm going to go left-hand side. I'm doing left-hand side. All right, I don't know what to do, but I do know what 1 is, right? So I'm going to say 1 minus 2 cosine squared theta over sine theta times cosine theta. I know 1 is equal to cosine squared theta plus sine squared theta minus 2 cosine squared theta all over sine theta times cosine theta. And then I can do some math here. So notice there's 1 here and there's -2 over here. So on top, you're going to get sine squared theta minus cosine squared theta. I think that should make sense. All over sine theta times cosine theta. That is different squares I possibly could factor it, but I don't want to do that. I think, like, if you think about this and this, these are really two fractions separated. And I think I want to go that route. So I'm going to take this, and this is kind of a difficult thing for students. I'm going to break this up into two fractions. So when we add two fractions, we keep the denominator and then add or subtract the numerator. So now we're going backwards. So then you're going to write these as two separate partial fractions. So you're going to say sine squared theta over sine of theta times cosine of theta minus cosine squared theta over sine of theta times cosine of theta. Kind of just to review, if I were to write this as one fraction, I'd keep the denominator and subtract the numerators. All right, and then I can simplify. There's a sine squared there and a sine there. So you would have a sine on top and a cosine on bottom because one of these sines would cancel out with one of the sines on top. Same thing with the cosines. So you get cosine theta over sine of theta. And then I believe I'm done. This is tangent theta minus cotangent theta. And we're done. Yeah. I don't know. I was thinking the right might be easier. I don't know. I think in this case the right would be easier, but I don't know. Again, I try to like take the one that looks the hardest. 17 doesn't look bad. I get cosine theta is equal to sine of theta times cotangent of theta. Right hand side. I don't know why this one looks so easy. Sine of theta. Oops, I'm gonna erase this. Sine of theta times cosine of theta over sine of theta. These sine of thetas cancel out, and you just get cosine of theta. Done. Done, done, and done. 19. That's my last one. I just got tired. All right, so then I say cosine of theta times cosine of negative theta. Oh my God, what am I doing? I'm tired. Gotta go to bed. Cosine of negative theta minus sine of theta. This one feels a little not interesting. We're showing one. Obviously, I'm gonna start with the left-hand side. So I got cosine theta times cosine of negative theta minus sine of theta times sine of negative theta. And then I'm going to use my inverse reciprocal negative. Cosine's an even function, so it's going to like eat the negative. So then this gets cosine theta times cosine theta. Sine's an odd function, so like the negative is going to come out. So I get negative times sine of theta times negative sine of theta. And then we have this like negative of a negative, so that's going to turn into a positive. So you have cosine squared theta plus sine squared theta. And we should all know that that's equal to 1. I made it to the right-hand side. We are done. Am I done? Am I done? I don't know. Let me look at 21. Oh my God, 21 looks rough. Holy cow. Let me do a couple more of these. Let's go 20, because I want to break this up for 2 days, maybe 3 days. All right, 21. I got secant theta minus tangent theta is equal to 1 minus sine theta over cosine of theta. Right-hand side. Left-hand side? Left-hand side. Right-hand side. Left-hand side. Left-hand side. All right, secant theta. I think they're both equally easy. So secant theta minus tangent theta. I'm going to go in sines and cosines because that's sines and cosines. So I'm going to say 1 over cosine of theta minus sine over cosine of theta. And then I'm going to say this is 1 minus sine of theta over cosine of theta. And I'm done. Boom. Next problem. 23. There's lots of problems. Lots of opportunities for success. Secant theta times cosecant theta. What? Isn't that just 1? No, I lied. Equals tangent theta plus cotangent theta. Right, left, right, left, right, left. I'm going to go right this time. Tangent theta plus cotangent theta is equal to, I'm going to go to sines and cosines. Or should I go to secants and cosecants? Okay, I'm going to go to secants and cosecants. Remember that tangent, like different color here. Tangent squared theta plus 1 is equal to secant squared theta. If I wanted to, I could say tangent squared theta is equal to secant squared theta minus 1. I can use that. And then you plug it in here, plug it in there, and then you plug the other one in there, so it'd be cosecant squared minus 1. And I think good stuff happens. I hope. I hope. So then what would that turn into? I'm just going to do the left-hand side. I mean the right-hand side. I'm not going to use that. I'm just going to go to sines and cosines. Hope for the best. Let's see. Sine theta over cosine theta plus cosine theta over sine of theta. Again, I want to change this into a product. So, I mean, obviously that's a single fraction. So we'll go ahead and do that. Least common denominator is cosine sine. So this term is missing a sine. So this is equal to sine squared theta. This guy's missing a cosine. So I'll say plus cosine squared theta. And the denominator is going to be cosine theta times sine of theta. The top is sine squared plus cosine squared, which is just 1. The bottom is cosine theta times sine of theta. If I want, I can write this as 2 partial fractions, 2 cosine theta times 1 of sine of theta. You can verify that if you multiply the numerators again, multiply the denominators. 1 over cosine squared. 1 over cosine theta is secant theta, and 1 over sine theta is cosecant theta. And I am done. What number was that? All right, 25. On to 25. What the hell? That looks terrible. These are getting hard. These are getting hard. Oh my god, there's lots of them. There's lots of them. These are getting really hard. All right, no, I got it. I'm good. I'm good. Here we go. Sine theta plus cosine theta squared is equal to 2 plus secant theta times cosecant theta over secant theta times cosecant theta. Okay, finally, like, this is difficult. This is going to be not so fun. I gotta think. Nah, thinking's overrated. I feel like I have to play with the right-hand side. Feel like it. I almost feel like I have to take a time out and like work this out, so I don't look too foolish. Okay, I'm gonna play with the right-hand side. And what's the worst that could happen? You know, I like mess up and then I just reset the video where I messed up. It's not too bad. It's not the end of the world. It's not the end of the world. Okay. Cosecant theta. Okay. Let's just work it out. Let's see what happens. I get 2 plus, I'm going to change everything to sines and cosines. It just feels like it. The result is in sines and cosines. So this is 1 over cosine of theta. This is times 1 over sine of theta. All divided by 1 over cosine of theta times 1 over sine of theta. Dude, this is like a spark. This has to be a sparkle problem. I feel like it's a waste. And this is not even the hardest problems. These are on the B section. There's a C section to this. I like it. I like it a lot. Okay. I'm going to multiply. Okay, so I guess I'm going to add a step here. This is equal to 2 plus 1 over cosine of theta times 1 over sine of theta. If I want, I'm going to write this as a single fraction. Just multiply them together. 1 over cosine of theta times sine of theta, all over, and I'm going to write this as a single fraction. I imagine some people would skip that step. And then I'm going to multiply by the reciprocal. So I'm going to oh. And when I multiply by the reciprocal, and again, I'm probably doing too many steps here, 1 cosine sine theta, and then multiply by the reciprocal, cosine theta times sine theta, and then I distribute to each term. Oh, dude, I see it. Wow, I didn't think I was going to see it. I don't know how many students are going to be able to see this. But when I distribute to the second term, I get plus 1. But I know what 1 is. 1 is, so I say 2 cosine theta times sine theta. 1 is cosine squared theta plus sine squared theta. And then I want to get in the order that they have it. Is it? Okay, sines first. So I can rewrite this as sine squared theta plus 2 cosine theta times sine theta plus cosine squared theta. And this is a quadratic. I'm guessing the intent is to go left to right. Don't know. This is a quadratic, but I really like this problem. All right, so what times what would give us a sine squared? This would be sine theta. This would be sine theta. And then what times what would give us a cosine squared? This would be cosine theta. This would be cosine theta. And we're adding these two together. And when you FOIL them out, when you FOIL these things out, you'll see it does work. Like that, the outside is cosine times sine, and the inside's cosine times sine, and you have 2 of them. It does work. So therefore, this turns into sine theta plus cosine theta squared. Dude, I like that problem. Really good problem. Good sparkle problem. And like either going left to right is super easy because this is a B type of problem. I think they said B. I don't know. Don't they label these? Anyway, this is a good problem. I like it. All right, thank you. Oh, it long. Ugh.